The universe has two walls you can never climb over. One is the speed of light. Anything with mass can never reach the speed of light. The other is absolute zero, minus 273.15 degrees Celsius. This is a number that makes every physicist's scalp go numb. So cold it can freeze time at the physical level. The coldest place on Earth, Antarctica, is only around minus 80 or 90 degrees. But 5,000 light-years away from Earth there is a cloud of gas called the Boomerang Nebula. Its temperature is minus 272 degrees. But it is still more than 1 degree away from absolute zero. That 1 degree gap is something the entire universe has failed to cross for 13.8 billion years. No matter what corner of the cosmos, no substance has ever truly reached minus 273.15 degrees. Because the universe hard-coded a rule into its deepest code, nobody is allowed to touch this temperature. In 1800, a French scientist named Gay-Lussac took a sealed glass tube, pumped gas into it, and heated it to see how much it expanded, then cooled it to see how much it shrank. What he discovered sent a chill down people's spines. No matter what gas you used, every time the temperature dropped by 1 degree, the volume shrank by a fixed amount. He plotted his data on a graph. All the points lined up perfectly into a straight line. Then he did one more thing. He extended that line downward. The line kept going, all the way down to minus 273 degrees, where it intersected the horizontal axis. What did that intersection mean? It meant the gas volume became zero. But how could matter possibly shrink into nothing? Gay-Lussac immediately realized. That wasn't where matter disappeared, that was the end of temperature. The universe had put up a sign there that read, "Road closed." Later, scientists used more precise instruments to recalibrate, and fixed the number at minus 273.15 degrees. That's where absolute zero comes from. A forbidden zone of the universe derived purely from mathematics. Now that we know what it is, the next question is, what makes it so terrifying? A lot of people think it's just a bit colder, you could always wear more clothes. But absolute zero is nothing like the cold we talk about in daily life. First, let's talk about what temperature really is. When you touch a cup of hot water and feel it's hot, it's because the water molecules are crashing around wildly, slamming into your skin and creating the sensation of heat. When you touch an ice cube and feel your hand freeze, it's because the molecules in the ice are behaving nicely, barely moving at all. So temperature, at its core, is describing how agitated molecules are. Highly agitated means hot, calm means cold. So what if molecules stopped moving completely? That state is absolute zero. Now imagine a scene. Someone instantly throws you into a space at absolute zero. The tens of trillions of cells inside your body, and the countless atoms in each cell would all freeze at the same instant. You would turn into a statue, locked in the exact pose of that final second. And this statue would never decay. Why? Because the bacteria that cause things to rot would also be frozen. They wouldn't be able to move either. No force could decompose you. You would remain in that posture, all the way until the day the universe ends. Doesn't that sound like a kind of immortality? But don't get happy too soon. You wouldn't feel any of it, because all the atoms in your body would be motionless. Your consciousness would shut off as well. That's the cruelest part of absolute zero. It gives you an eternal body, but takes away your ability to perceive eternity. If all of that still sounds like pure imagination, then what comes next is something scientists have actually witnessed in the lab. As temperature keeps approaching absolute zero, matter starts performing acts that make you question reality. The first act is called superconductivity. In 1911, a Dutch physicist named Onnes accidentally discovered while tinkering with low-temperature equipment, that when mercury was cooled to around minus 269 degrees, its electrical resistance suddenly vanished. Not reduced, but completely gone. You run a current through a superconducting coil, then cut off the power. The current inside won't stop. It doesn't slowly decay, it just keeps going forever. In theory, that current could keep flowing until the sun burns out and the Milky Way falls apart. Why do the wires we use every day heat up? Because when current flows, there is resistance. And energy turns into heat while overcoming that resistance, wasted into nothing. But superconductors delete that rule. Electrons move through them without any obstruction, not a single bit of energy is wasted. MRI machines in hospitals and maglev trains all work on this principle. The second thing is even stranger, it's called superfluidity. If you keep cooling helium gas down to around minus 271 degrees, it turns into a liquid. But this liquid is nothing like what you're used to. It has zero viscosity, absurdly smooth. You pour it into a cup, and it will climb up the walls by itself, spill over the rim, and flow out. No one touches it, no external force acts on it, it just wants to escape. Even crazier, if you put it in a container that looks sealed, it can seep out through atomic scale cracks you can't see with your eyes. As if the stuff had become sentient and knew where the exits were. But that's still not the wildest part. What comes next is the real explosion. In 1995, two American scientists created something called a Bose-Einstein condensate. This is the fifth state of matter. After solid, liquid, gas, and plasma, it only appears when you get infinitely close to absolute zero. What's so weird about it? Thousands upon thousands of atoms suddenly lose their individuality and become one thing. Not physically squeezed together, but truly merged into a single entity. They vibrate at the same frequency and move in the same direction, like a group of people suddenly sharing one single brain. Later, scientists witnessed a scene in a space laboratory. The same atom appeared in two different places at the same moment. You heard that right. The same atom, at the same instant, in two places. In our everyday world, that is absolutely impossible. You can't stand in the kitchen and the bedroom at the same time. But under such extreme low temperatures, the insane rules of the microscopic world start invading the reality we're used to. After all that, you might ask, how low have humans actually pushed temperature? In 2021, a research team in Germany set a record. They cooled a tiny cloud of atoms to just 1/38 trillionth of a degree above absolute zero. That number is 0.000000000038 Kelvin, a decimal point followed by a long string of zeros. To reach this temperature, they dropped the container holding the atoms from the top of a 100-meter tower. During a few seconds of free fall, the atoms escaped the pull of gravity. Their motion slowed to almost zero. For those few seconds, that tower became the coldest place known in the entire universe. But even at that level, they still couldn't touch the line. Because quantum mechanics forbids it. There's a concept here called zero-point energy. Simply put, the universe decrees that every particle must retain a minimum amount of energy and can never be completely still. Because if a particle were completely motionless, then its position and velocity would both be exactly determined. And quantum mechanics has an iron law. Position and velocity cannot both be measured precisely at the same time. So the universe set a lower limit for all particles. Like a video game character whose health bar can never truly hit zero. You can get infinitely close to that line, but you'll always be missing that last breath. Also, absolute zero is tied to the ultimate fate of the universe. In physics there's a law called entropy increase. In plain language, it means heat always flows from hotter places to colder places, until both sides are equally cold. This is a one-way street, irreversible. The sun is burning, but one day it will burn out. Black holes are devouring everything, but in the end they will slowly evaporate away. When the last trace of heat in the universe has dissipated, all of spacetime will infinitely approach absolute zero. There will be no more stars shining, no more planets spinning, no more chemical reactions happening. Even time itself will lose all meaning. Scientists have a name for this ending. It's called heat death. A heat death universe has no light, no heat, no sound, no motion, only eternal silence. The Boomerang Nebula is a trailer for that future. It's colder than the average temperature of the universe. Like a messenger from the end, telling us in advance, your universe is slowly cooling down. So you see, the universe used the speed of light to lock down space. So no civilization can ever roam the sea of stars. And it used absolute zero to lock down time. So no life can ever exist forever. These two shackles trap all intelligent beings in their own tiny corners. But if you look at it from another angle, it's precisely because of these limits that this moment becomes precious. The atoms in your body are still moving, your heart is still beating, your brain can still generate thoughts and emotions. These things so ordinary you never even notice them, are exactly the luxuries that absolute zero can never reach. The end of the universe is not an ocean of fire, but total silence. That silence is creeping toward us with every passing second, but that's trillions of years in the future. So for now, while our bodies still have warmth, let's live every future day as well as we can.